Hello everyone. In this video, we are going to discuss about the problems related to single stub matching. So before entering into the topic, let's discuss about the impedance matching by stubs. So we have seen that the section of transmission line can transform and match impedances. So it is also possible to connect section of either open circuited line or short circuited line. It is called a stub. And this stubs is connected in shunt with main line at some point or points to affect impedance matching. So this is called as stub matching. There are two types of stub matching. One is single stub matching and another one is double stub matching. So here we are going to design a single stub matching. So in order to go with the single stub matching, we have to find the location of the stub and also the length of the stub. So the location of the stub is denoted by LS using the reflection coefficient K. So this LS is given by lambda by 2 pi tan inverse of square root of ZR by Z0. Here, this ZR is nothing but your load impedance and Z0 is nothing but your characteristics impedance. In the dissipation less line, this Z0 is can be written as R0 also. And also we can use this second formula also. LS is given by lambda by 4 pi psi plus pi minus cos inverse of K. So this K is nothing but reflection coefficient. And coming to the length of the stub. So length of the stub is denoted by LT and LT is given by lambda by 2 pi tan inverse of square root of ZR into Z0 divided by ZR minus Z0. And also we can write LT has lambda by 2 pi tan inverse of square root of 1 minus mod K square divided by 2 into mod K. And lambda is nothing but the wavelength. So if in question, if they have given the wavelength, we can find the frequency. So if they have given the frequency, we can find the wavelength. And already we know the reflection coefficient K is given by ZR minus Z0 divided by ZR plus Z0. And in the polar form, this reflection coefficient is denoted by the magnitude as well as the phase side. So the first problem is determine length and location of a stub of a single short-circuited stub to produce an impedance match on a transmission line with characteristics impedance of 600 ohm and terminated in 1800 ohm. So they have given the characteristics impedance has 600 ohm and also the load impedance has 1800 ohm. So the load impedance is denoted by ZR and the characteristics impedance is denoted by Z0. And in question, they have asked you to find the length as well as the location of the single short-circuited stub. So what is the formula for the location as well as the length of the stub? So already we have seen the formula, right? So the first, in order to find the location and length of the stub, we have to find the reflection coefficient K. So K is given by ZR minus Z0 divided by ZR plus Z0. If you know the load impedance and characteristics impedance, we can find the reflection coefficient. So first we have to find the reflection coefficient using the formula. So K is equal to ZR minus Z0 divided by ZR plus Z0. ZR is nothing but 1800 and 1800 ohm and Z0 is nothing but 600 ohm. So if you use this formula, you will get the reflection coefficient as 0.5. And in the polar form, we can write this as magnitude and phase is 0 degree. Now we have found the reflection coefficient and then we have to find the location of the stub. So the location of the stub is given by LS is equal to lambda by 4 pi psi plus pi minus cos inverse of K. So here phase angle is nothing but your angle in the reflection coefficient and the magnitude mod K is nothing but 0.5. So you can substitute in this formula. So LS is equal to lambda by 4 pi. So phase angle is 0, 0 plus pi minus cos inverse of your magnitude is 0.5. So if you substitute in this formula, you will get the length of the location of the stub as LS is equal to 0.167 lambda. In question, if they have mentioned the wavelength, you can substitute in lambda and you can find the location. And coming to the length of the stub, LT is given by lambda by 2 pi tan inverse of square root of 1 minus mod K square by 2 into modulus of K. So here we know the reflection coefficient already. Mod K we know, right? Mod K is 0.5. Just substitute in this formula and then you'll find the length of the stub. This is how we have to find the location as well as the length of the stub using the reflection coefficient.